So we understood what is memory, right? So memory is nothing but the ability for an LLM to store information about the past conversations, right? So as I mentioned, we have different types of memory: conversation buffer memory, conversation buffer window memory, conversation summary memory, and several other types available, which we will go through. So now let's see how we can give memory to an LLM by using conversation buffer memory, right? So as the name suggests, the LLM keeps the entire conversation history in the memory, right? So that means it stores every single conversation in the memory. So when we have lengthy conversations, we will lose the context after some time because of the context window limitation. Or once it reaches the maximum token, then the LLM may ask you to initiate a new task or session, right? And the drawback with conversation buffer memory is it passes the entire conversation history, right? That is more context window, so more GPU processing, so more tokens and more money, right? So let's go to VS Code and start building the project and see how we can give memory to LLM by using conversation buffer memory, right? So this is our build generative AI applications workspace, and underneath we created several projects here. So we have seen RAG, chunking methods, prompt engineering, document loaders, right? Now let's see memory, right? So here I've created an empty folder and I named it memory demo, right? So let's add this folder to our workspace, build generative AI applications, right? So come to the Explorer and right click, add folder to workspace and select memory demo and add. Click yes, right? So now we got the memory demo folder added to our workspace, right? Now, so make sure you select this folder and then file, new file, Python file, and let's try to save this file and make sure you go to memory demo. Let's try to save this file as conversation buffer memory demo and save, right? So the first thing is, let's try to import all the required packages from LangChain, right? So here you have to install LangChain Anthropic. If you already installed, you don't have to install this again. We have used this Claude Anthropic already in our RAG application, right? If you have already installed here in our RAG project, you don't have to install it again. If you haven't installed already, make sure you install LangChain Anthropic. So we will be using Claude Anthropic, right? So instead of Claude Anthropic, you can use OpenAI as well, right? Or instead of these paid LLMs, you know Anthropic is paid LLM and also OpenAI is paid one, right? So instead of these paid LLMs, you can also use any other open source LLMs as well, either from Hugging Face or Ollama. So we have several other open source options as well. And as you know, LangChain is model agnostic framework. That is, you can use any model and the LangChain supports that model, right? So you do not have to rely on just one model, right? So what we did here so far, we imported all the required modules from LangChain. First one is Chat Anthropic, because we will be using Anthropic LLM and we will be chatting with that. So that's why we imported Chat Anthropic, and then conversation chain and conversation buffer memory. And these two are to load the environment variables, right? So we will be storing our Anthropic API key inside the environment variable, and we will be loading the environment variables from the environment file by using load_.env and using it in our code, right? So first thing is, let me try to create an file and let me name it .env, and inside this let's try to store our Anthropic key, right? So you have to store your key. And when we were implementing RAG application, I've already shown how to get the API key from Claude Anthropic, right? So make sure you store your key here. Okay, let me close this. So far what we did, we installed all the required packages and then we loaded the modules that are required from LangChain, right? And also we created an environment file and stored our API key over there. And we will be using Claude Anthropic. Instead of Claude Anthropic, you can use any other LLM as well. Okay. So first thing is, let's try to load the environment variables from the .env file, right, by using load_.env function. And once we load the environment file, next thing is let's try to read the key. This is the name we saved inside the environment file. So we are trying to read the API key by using getEnv function, and we are assigning to a variable called Anthropic API key. So let's close it here. And now this Anthropic API key, let's assign this to environment variable, which is nothing but Anthropic API key, right? So with this, we are able to load environment variables from environment file, and then we read the API key and we stored inside our environment variable Anthropic API key. Okay. Now next thing is let's set our LLM. So we will be using Claude Anthropic, right? So let's try to initialize the LLM. And here we are using Chat Anthropic, which is from LangChain Anthropic. And the model is Claude 3.5 Sonnet. So that is our LLM. So with this, we initialized our LLM. So our LLM is ready to chat. So instead of Chat Anthropic, you can use any other models too, right? So you don't have to just use Claude Anthropic LLM. Instead of this, you can use Chat Ollama, right? If you want to use Ollama model, then you can replace this Chat Anthropic with Chat Ollama, right? So go to Google and type Chat Ollama, right? And then click on this. So you can see we have the support from LangChain, right? So all we have to do is install LangChain Ollama package. Once you install the package, then you can make use of this Chat Ollama module, which is inside LangChain Ollama package, right? So this is how you can use open source LLM, which is nothing but Ollama, right? Or if you want to use OpenAI, right? So go to Google and type Chat OpenAI and click on this LangChain URL, and then here it shows how to install the package. So pip install LangChain OpenAI. Once you install the package, then you can get Chat OpenAI module, which is from LangChain OpenAI, and you will be able to initialize the LLM, right? And make sure you import the corresponding packages, right? So all we have to do is we just have to change this one line if you want to use any other LLM, right? And the rest of the code will be as is. So we have our LLM ready. Now the next step is we want to give memory to the LLM, right? It is so simple here. You just have to write one line, and that is the advantage of using LangChain. So how can we provide memory to LLM? So here we are using ConversationBufferMemory, right? This ConversationBufferMemory we are getting from LangChain memory, right? And if you want to see the documentation of ConversationBufferMemory, so you can just go to Google and type ConversationBufferMemory and go to the LangChain documentation. So if you notice here, underneath memory, we have different types of memories, right? Conversation buffer, conversation buffer window, and conversation summaries. So we will implement few types, and then you can deep dive depending on your requirement, right? So you have the documentation here, you can go through. So with this, we added memory to the LLM, right? Now, once we have the LLM ready with memory, now the next step is we need to wrap both LLM and memory by using this chain, right? Here we are using conversation chain. So by using conversation chain, we are passing 3 parameters. The first one is memory. So memory we've already created here, and the LLM we already initialized here, and verbose is equal to true. So this is how we wrap both memory and LLM by using conversation chain. We are trying to bind the LLM with the memory by using conversation chain. So what is chain? Chain will help you to do multiple complex tasks together. So more on chains we will discuss later. We have a separate section where we will deep dive into chains, right? So this conversation variable here is the chain that we have created, which has LLM and also memory, right? So we have an LLM which is Anthropic, and this LLM has memory, right? So once we bind both LLM with memory by using chain, now we are ready to start the conversation with our LLM, right? So let's try to chat with our LLM. So inside conversation buffer memory, we have a method called predict, and for this we are passing input is equal to hi, my name is Mala, right? So this is how we are trying to chat with our Anthropic LLM. So let's try to save this code and click on run Python file. So here you can see entering new conversation chain, prompt after formatting. Always look for the current conversation, right? So human, hi, my name is Mala, and this is how AI responded. Hello Mala, it's a pleasure to meet you. My name is Claude and I am an AI assistant. I am always excited to chat with new people and learn about their interests and experiences. Is there anything in particular you would like to talk about today? I would be happy to discuss a wide range of topics from science and technology to arts and culture. Or if you prefer, we could just have a casual conversation and get to know each other better. Please let me know what you would enjoy, right? So this is our input human, and this is how Anthropic responded, right? So what we are trying to do here, we installed all the required packages, and then we imported the modules, and then here we tried to load the environment variables from the environment file, and we got the key and we stored inside our environment variable, and then we initialized our LLM by using chat Anthropic, and then we created the memory, and then we tried to bind the LLM with the memory by using conversation chain, and then we are trying to chat with our LLM. The first conversation is hi, my name is Mala, and this is the response we got from LLM after executing. So here the current conversation is nothing but memory, right? So always look at the current conversation. Human means it is me, and AI is nothing but Claude Anthropic. So this is our first conversation. First conversation means I have asked something and the LLM has provided the response. So conversation means both the question that we asked and also the response that we got from the LLM, right? Question and response together is called conversation. And second conversation means again I've asked a question to LLM and the LLM has responded, right? So this is our first conversation with our Claude Anthropic LLM. Now let's try to do another conversation, right? So let's try to ask another question. So inside conversation buffer memory, we have a method called predict, and we are passing the input as I'm doing well, just having a conversation with an AI, right? So let me save it and let's rerun the code. So this is what the LLM responded for the second question, right? So if you notice here, this is our current conversation, right? Now you can see the LLM retained the first conversation history as well. So this was our first question. Hi, my name is Mala, and this is what LLM responded. And this is our second question, right? And then this is what LLM responded for our second question. So that means it is trying to retain every single question and the corresponding answer, question and the corresponding answer, right? And now let's try to ask third question. What is AI, right? So let's try to rerun the code. So this was our first question, and this is what LLM responded, and this is our second question. This is what LLM responded, and this is our third question. What is AI? This is what LLM responded for our third question. So which is nothing but what is AI, and this is what it is responded, right? So that means for every single question that we ask, it is trying to retain the previous conversations as well, right? So here we only asked 3 questions, right? As we are having more conversations with the LLM, that means we are using more tokens, right? So the context window is nothing but both input and the output response together, right? The total number of tokens, right? That means the entire conversation will be converted into tokens, and the problem here is the LLM is trying to remember the entire history, right? Not just the current question. It is trying to remember the entire conversation history. So which means we are using more tokens. So that means more GPU processing, so more cost, right? Now we have asked, hi, my name is Mala, I'm doing well, just having a conversation with an AI. What is an AI, right? Now what is the proof that our LLM Claude Anthropic is remembering, right? So we have added this memory, but what is the proof that our LLM is able to remember what we have told, right? So the first conversation, what we said, my name is Mala, and we did 2 other conversations. So after having few conversations, now let's try to ask what is my name, right? To test if the LLM actually remembered the context or not. Okay, so this is what we are trying to pass. The question is, what is my name, right? So let me try to rerun the code. So whenever you rerun, right, so always look for the current conversation, right? So the first question and answer, second question and answer, and third question, what is AI and answer, what is my name? So you can see your name is Mala. If you see here, your name is Mala. You introduced yourself at the beginning of our conversation and I made sure to remember it, right? So the LLM was able to remember the name because we added memory to our LLM, right? So this was our first conversation, and after that we did 2 other conversations. Finally, we are testing LLM if it actually remembered our name or not, right? So after few conversations, it still remembered, right? So this is nothing but memory, right? So what is happening with conversation buffer memory? As the name suggests, this is trying to keep the entire conversation history in memory, right? Because we asked 4 questions and it tried to keep the, if you see the current conversation, so this was our first question and answer, second question and answer, right? And then third question, what is AI, and the corresponding answer. And finally, what is my name? That is the 4th question and the answer, right? So what is happening here? It is trying to keep the entire conversation history in memory to help contextualize the answer to the next user question, right? So while this sounds very useful, only drawback here is that it keeps all of the history, right? So up to the maximum limit of specific LLM, right? We know each LLM has a fixed context window size, right? And for every question we asked, it tried to pass the whole previous discussion, right? That is, it is more tokens to the LLM API, right? So this can have significant cost impact, right? Because API costs are based on the number of tokens processed and also the latency impact as conversation grows, right? Because here we used 4 conversations and this is how it created, right? So you know this will be converted to tokens and processed, right? So that's about conversation buffer memory. So let me quickly summarize. So first what we did, we installed all the required packages and then we imported all the required modules, and here we used Claude Anthropic as our LLM. Here we loaded our environment file and read the API key, and we initialized our LLM by using Chat Anthropic, and the model that we are using is this. And the next thing is we added memory to our LLM by using conversation buffer memory, right? Once we have the memory and LLM, we try to bind LLM with the memory by using conversation chain. And conversation chain we imported from LangChain chains. And once we have the conversation chain ready, we started our conversation with Claude Anthropic LLM, right? The first question is, hi, my name is Mala, and the LLM responded. And the second question we asked and LLM responded. Third question and fourth question, finally we tried to test the LLM if it actually remembered the name or not, right? Which is nothing but the memory, right? We told LLM to remember the conversation because at the beginning we introduced the name as Mala. It tried to remember it and try to respond the name as Mala, right? And the only drawback with this is it will try to keep the entire conversation history for each and every question, right? So that means more tokens and more GPU processing and more money, right? And at one point, once it reaches the maximum limit, then the LLM may not be able to respond anymore, right? Because the LLM might ask us to initiate a new session or task, right? With that, we may lose the context as well, right? So that is one of the disadvantage of using conversation buffer memory. So with this, I hope you are clear on how to initialize an LLM, how to add memory to an LLM, and how to bind LLM with the memory by using conversation chain, and how to start doing the conversations with an LLM. All right. Thank you.